An ellipse is more egg-shaped. To make something egg-shaped, I need to change its radius. In other words, I need to have the radius this way be different than the radius this way. How do we do that equation-wise is as follows. We would note x, we do the same thing, plus h squared. We would have still y plus k squared, and still would be equal to the radius, except that I have two different radiuses, don't I? So what we're going to do is we're going to set the right-hand side equal to 1 instead. We'll set this equal to 1. When I set that equal to 1, I'm going to set the radiuses individually. I'm going to put a different radius here and a different radius here. What that means is if this is 9, square root of 9 is 3, therefore it goes left or right 3. If this is 4, sorry, if this is, this is 4, square root of 4 is 2, that means it goes up or down 2. Now, the way to define a foci, we define an ellipse is as follows. You take two pins, two nails, and you nail them into the board. I'm not going to do that because this is an expensive board. And then you take a piece of string, a loop, as it were, and you take a pin, and you loop the string around the two pins, around the two nails, and you put your pin right here, and then you do what?
Draw.
You just draw it, and it's going to give you an egg-shaped drawing, right? Because when you get here, it's going to be more narrow. When you get here, it's going to have to be like this, right, to have the same space. So that's what makes an ellipse. What do we call these 2 points? Foci. Okay? And so if you were required to draw something, let's say you were going to carve an elliptical shape something or other, you would have to locate the two what? The two foci. You'd have to get on a string and do it just like we're doing it. Oddly enough. As crude as that is. So the formula ends up looking like this. Now it does say minus on the sheet. If you want to change it to a plus so we don't have to learn new things, go ahead and do that. It says minus on the worksheet, but let's just not do that, shall we? It says minus up here on this worksheet, so please fix that if you want to. So this ellipse, would have a distance, here's the center, which by the way would be what? Negative h, negative k, right? It would be a this way, a that way. It would be b down and b up. There's one other thing we need to be able to find, and that is the foci. The foci are always along the major axis. This is the part that's going to get you. Major axis is the big one. So since the big one, in this case, it would be what? So my drawing to scale would be A. And so my foci would be here and here. How do I know how far they are from the center, though? There's a cute little formula. Formula goes like this. It's the square root of absolute value A squared minus B squared in absolute value. And that would be how far the foci is from the center in the direction of the major axis.
Why does the foci matter in this case?
Because how else would you draw that?
Just guess. Draw around like.
Let me give you a whole different thing. Do you realize way back when, in the good old days, actually let me back up. Who's the person who discovered that we go around the sun? Plato. No, Plato was 100% convinced of the celestial spheres because it made sense to him. Galileo had no idea that we were going around there. He was told by a priest that we did, and he was disturbed. He thought it likely that we went around the sun, but he had no proof, so he didn't say anything about that. In fact, he saw somebody burned alive during his lifetime for saying we went around the sun, so therefore he didn't say it. No. He saw somebody burned alive. That's why he was not burned alive, because he didn't say it. The guy's name was Johannes Kepler. Kepler was just doing math. He was a geek, nerd, complete math nerd. More about him if you ever take a physics class. But it boils down to this. He wrote down equations for the motions of all the planets. He didn't make a single judgment about it. He just simply said the planets are all traveling in ellipses, which they do. And as a result, he also, in order to make the ellipses make sense, he had to find the foci. So he did. He found the foci. And guess what we discovered was at the foci?
A moon.
The sun. The sun's at the foci. So what do planets do?
Egg around the sun.
They go in egg shape around the sun. Now, that's all he said. He said the planets travel in ellipses around a foci, which is located where the sun is. That's all he said. And for approximately 7 years, nobody realized what that meant. Even though he'd done the math. Because he was a math nerd and he wasn't trying to make a statement about science at all. Okay? So foci do have meanings. And I'll give you that second example before. If you have one of these, or one that go on directly on your eyeball, if you have astigmatism, you can't deal with a circular lens. You need an elliptical lens. So how do they do that? They take 2 points, set the foci, and then they grind it to equidistant to the 2 foci. Okay? That's how they go about it. And so all the lenses, when they go to the company, all they do is measure the foci of lenses. That's all they need. They don't care what your vision is. Doesn't matter to them at all. The other people need to find the foci for them. And that's what they do. And I'll give you another 20 examples where the foci are important. Notice what I've stopped talking about, though. The directrix. Is that really important to us? Not so much. Not so much. Not a lot of great examples how this is. Okay, let's flip this over. You should be able to do problem number 1 with the great explanation I've given you. I can drain. Where's the center, really? Where's the center? 0, 0. How'd you get that? Because it's the center and it didn't get moved, right? Yeah. Okay, good. All right. Now I'm going to draw this thing. How about part do we go left, right? I go 3 left, right. How far do we go up, down?
4.
4. Got my lips. That was easy. Now I'm going to finish answering all the questions, though, because there's some more questions over there. I found the center. Oh, man. How do I find the foci? Really? Formula time. Square root of. Absolute value of. A squared.
Minus B squared.
Minus B squared. And absolute value bars. So now I'm going to put. Now here's something interesting. A is the square root of this, right? So what is it squared? Just the stinking 9, right? Because it's square root of 3, square root is 9. We're just going to use 9 and 16, aren't we? But that's okay. We just do that. So I got 9 minus 16. And if you want to, you can square root it and square it and get the same answer. 9 minus 16 is -7. Absolute value of -7 is 7. All right, folks? Now, the foci. Which direction are they in? Which direction are they in? That have to be the longer direction, right? So it's going to be root 7 up this way and root 7 out this way. So there's my foci, right? How do I write my foci, what foci are? They'd be what in the x direction? 0. They'd be square root of 7. And what's my other foci? Because there's always 2.
0,
Negative root 7. So far, so good? Then it says, what's the length of the major axis? How long is the major axis? 8. How about the minor axis? 6. Anything else? Done. Got it? All right. Should be able to do these problems. Start working them.